Alright, you guys, this is another step forward. I am doing a retake because I got the box printed. So here's the deal. We have the dry fit of the experimental apparatus. The circular attachment is the crank. This bar piece with the slot is the lever, and it's attached here to the bearing threaded mount on a mounting plate. I have some M4 screws and nuts fitting it in that I 3D printed. I'll go into problems in a sec, but I just want to show you this is basically proof of concept because the motor will be constantly spinning in one direction. Excuse me, young man. Okay, excuse me. We have this spinning in one direction. Excuse me. Okay, he wants to sit there. The motor will be spinning in one direction, and then as you can see, it's not the best fit right now, which I'll go into in a sec why. But I have an M5 screw, and then a nut, then the lever, and then another nut. And then on the motor, I printed a new bracket to mount the motor that compensates for the 5-degree sag from this vice clamp. And then the mount is not 100% secure. We'll go into that in a sec, but it's proof of concept because then the plexiglass ruler will go across the output and it'll have the plexiglass protractor attached, which will then swing through this coil, okay? And then months ago, I printed the attachment on the back, so there's a magnetic angle encoder in here, and I don't have the leads on. But, okay, we have the 4 leads coming off of the 2 coils that are controlling the motor, right? And then I have now this electronic enclosure box here, which we can see we have room for the leads on the coil for, and then we have the leads for the coils on the motor going into a nice little slot here. Before I open it up, we have a little opening for the, we can access the USB ports, I'm not using them, but then the Ethernet connection going to the router. I don't have Wi-Fi, but then this is going to be connected hot wired to my laptop to control the Raspberry Pi inside. And then I have another slot for obviously USB-C power, and then like a 3.5 millimeter headphone jack that I'm not using, and some micro USB ports that I'm not using. And then I have a little output for my 12 volt power supply, which I now have a switch for, okay? And I've got this lid. We open it up, and it's not very pretty right now, but we've got the power supply. I don't have like the ADC and the driver plugged into the GPIO pins on the Raspberry Pi, but there are these standoffs going into the stand on the Raspberry Pi, so you can see it all fits nicely in here. The board is a little bit tight. It's not exactly flush with the bottom of the box. The box is a little bit too small, lengthwise or widthwise, depending on how you look at it, but I've got this lid. It's not the best, most snug fit, but now this is way nicer to deal with than having everything just like splayed out, okay? So We're going to go into problems now that I encountered today. One, I got there a little after 11:30 and I was like, okay, I've got the lid already printed, so I need to print the box, the crank, the lever. I was going to, print these plastic screws or bolts and nuts to fit it all together, and then print the 5 degree adjusted motor mount. And to recap, I had previously made an attempt to print the Scotch yoke, is what I'm calling it. It's basically like the same mechanism as a metronome if you haven't been watching my past tinkering vlogs, but it turns out what the main problem was is that I was making the G code from Prusa Slicer for the wrong 3D printer model. So that makes a huge difference. So I was encountering things like I'd be printing, this is for example my first try at the box, and an edge would lift off the print bed, and so I would have to stop. Turns out earlier today I got pretty far through and the same thing happened, and you can see here when it lifted up and the nozzle came back, the nozzle just like melted into the corner that was lifting off the print bed, and so I had to abort. So but I was able to dry fit and get a little bit closer, do one more iteration on my, for example, like the hole sizes, like for the D shaft on the motor that goes through the center of the crank here. I was able to dry fit it a little bit better, but I made the crank where it fits onto the D shaft of the motor a little bit too big. So this right here, there's a little bit of a give here. You can see I've got the collars on, so the axle of the motor is not moving, but there's this, little bit of looseness here. Also, I have, and I'll turn it here so it's aiming at the camera. You can already see, right? The collar is so thick, and then the nuts that are holding the crank on are a little bit too thin. The one that's in the center here is too thin, so there's this like potential for it to move, right? Which is a problem. And another thing that's a problem is that I'm holding the bearing threaded mount on here using these plastic screws and nuts I printed, but it isn't exactly tight on here. Partly because the nuts are not threaded very well for this small size. Okay, so like I'm turning one up here and it's just kind of like just spinning, it's not getting any tighter. So this is kind of sagging. But the mount, I made the right calculations and everything and did the geometry correctly because it is indeed level. And if this bearing mounted threaded piece with the M8 rod going into the M8 to M5 coupler and then the M5 output, this, if it were tight on here, I do believe that this would also be level, okay? But the plastic pieces, fastening, the bearing threaded washer deal, whatever you call this piece right here, the fact that these are held on with plastic screws and nuts is not essential. So I can replace those with metal. What is essential is that this middle nut here is thinner than the collar. So that's a problem because it's, loose here. But we can reprint that or we can get metal ones. In terms of have to have plastic, I printed these M8 screws, okay? And just holding in my hands the comparison of the metal one, it's like, okay, size-wise, pretty much spot on, we're gonna say. The plastic is way lighter than the metal. So that's probably gonna make a considerable difference when I have the plexiglass ruler and protractor attachment on here, because then there's not as much of a torque requirement to drive this from the motor because the attachment is lighter. But I printed these nuts for the M8 screws and it's like super loose. Kind of like the same problem with the M4 screws that I have holding the bearing threaded mount up here with for now. It just kind of like spins here. But if I put the plastic nut on the metal bolt, it actually fastens. And then if I put the metal nut on the plastic screw, it starts to fasten. And then I read on the original model for this that like if I hold the nut on with some pliers and then twist, it should end up fitting. But I'm a little apprehensive because when I was peeling the M4 screws off of the print bed, the threaded screw part and the head snapped off of each other. So that wasn't ideal. But, okay, like my first attempt at the, the box it didn't get very far. The crank, didn't get very far compared to what I have now. And the mount for this bearing threaded mount deal up here also didn't get very far. But my geometry is very, very, very close. And at least if I'm turning the crank and the lever manually, see the vice clamp is getting a little loose here. Let me tighten this up a little bit. If I just turn this manually, we can see that there is indeed symmetric, periodic, oscillatory output. It is loose also on the M5 output rod, let's say up here. Like if I just spin this, it's not flush with the lever. It's not snug fit. We want it so that when the crank and the lever are turning, this output is also turning. So it's a little bit off, and so I'll have to reprint some of this, obviously. Or I'm thinking what I might try to do is like glue some or epoxy some collars directly onto the lever and then use the collars, which have these little holes in them with little screws to like screw in, and that'll hold on to this M5 output rod. So I spent like 2 hours at the Makerspace this morning after I got there, shortly after 11:30, doing like a few iterations of printing that were just not happening. And I had to ask the people who are working there for help, which was like part of my intention of going there on a weekday, is that those people would be there instead of going in on the weekend when there's no one there to help me. So I consider this a success in terms of like I'm very close on the geometry. Also proof of concept of like I have these holes, right, that I could take the M5 screw and 2 nuts out of, and I could put it in one of these other holes, and I can change the output angle. Right now it's on the biggest one, which is 60 degrees, so you can see it swings out to a max, comes back in. If I were to put the M5 screw on one of the other holes in the crank, the output would be smaller because the diameter that the screw would be at is, or the radius that it's at rather, is smaller. It's closer to the center of the motor axle, so the output angle would be smaller. But I'm most pleased with my box here. The box, because the only problem that I had was that the hole over here where I have my USB-C power supply, maybe you can see I kind of had to file it because the USB-C wire was, it has that little plastic head on it, and it, you know, this hole right here, I didn't make, you know, long enough so that it could just slide in, so I had to file some of it in order for it to fit. But, you know, aside from the fact that the solderless breadboard is not flush with the bottom, other than that, it's like, I'm pleased with this box. This is a great prototype. It makes the footprint a lot easier to manage, because then I can just, you know, use the 12 volt power supply switch here on and off, or just, you know, put the USB-C plug in and out of the Raspberry Pi. The wiring is not as messy. And then, you know, here's the old mount, 90 degrees, metal, it's heavy. We've got the plastic one on there. But the plastic, all of these plastic parts, I'm worried that when I get this going, it'll like lock up and then the plastic will snap basically. And you know, aside from the nuts not fitting on the M8 screws, I'm at least very confident that this will make my, you know, plastic protractor attachment much lighter. And so I'm very pleased with that. And yeah, so there's just going to be one more round, hopefully, of 3D printing in the future. But, you know, it's like I keep saying, this is progress for sure. The only other major thing to build is a new base, because when I get the Hall sensor and everything set up, I'm going to have to basically have this whole thing like raised up, and then there'll be like wood here that goes up and then comes down. And so the coil will be free flying in the air, so to speak. And then down on the wood will be where the Hall sensor is. And if I didn't do that, then I'm going to max out the magnetic sensitivity of my Hall sensor and this metal base here. When the magnet is swinging through, there will be induced eddy currents. So I want to minimize that. But like, come on, you guys, like, look at this. This box is great. I mean, for a prototype box, like, boom, everything's in there. Solid. Here are all the outputs. There's plenty of room for the coil to go in and hook up to the ADC. And I mean, this is like, even if it doesn't work, this just like looks sick, if we're just being honest, right? Like, the fact that I designed the crank and the lever and everything by hand is pretty legit. And if nothing else works right now, it's like I learned a lot about 3D printing. I got to put my CAD drawing skills to the test, you know, and just sourcing all these parts and figuring out what I need to just like get this far, being that my inspiration was like a single YouTube video that's like 30 seconds long. I would say so far, this is a success, and I'm looking forward to more progress, more success. So see you guys in the next one.